Okay, let's start. In the previous lectures, we have started unit number 4. In that unit number 4, we have seen the Earth station. That is unit number 4 is Earth station. In that Earth station, we have seen different types of Earth stations are there. Okay, Earth stations are nothing but what? The basic concept of Earth. And that different types are nothing but what? Broadcast satellite survey. Just a minute. Fixed satellite service, broadcast satellite service, and mobile satellite service. These are the different types of Earth stations. And we have seen in mobile satellite services, we have seen different types of mobile services we are using. One is maritime, land mobile, aeronautic, personal, and broadcast. With those different types. We have seen single function, that is only your TV cable, that is your single stage function. Gateway station, that will be connected from one country to another country, that is gateway. And previously we have seen the Earth station architecture, how it is modified. The Earth station architecture is in that the baseband section, RF section, and support facilities. And this support facilities we have seen in the unit number 2, monitoring, control, everything, and power supply, everything you have covered. And next we have seen the Earth station design consideration. In this Earth station design consideration, you have to calculate some of the parameters, and those parameters are EIRP. You have to calculate the G by T ratio, and you have to specify the specific equipment which is going to install in a particular satellite. And the main important point, the 8 important considerations are there to consider the Earth station. Which are these 8 considerations? The 8 consideration is, the first point is high gain in the direction of wanted signal. Of course, we require the always high gain when the signal is required at the time of your Earth station, and low gain in the direction of unwanted signal. If there is a noise present in an undesired signal, there is a gain will be less. That is the point number 2. And in point number 3, low effective noise temperature for the entire receiving system. So noise temperature will be very less at the receiver if there is an unwanted signal. And we require the 4th number, that is high antenna efficiency. Always you have to reach at the receiver end, the efficiency will be more than 90 to 95%. So we expect that of efficiency. And we require continuous satellite pointing with the specified accuracy. Okay, the accuracy is very important. This accuracy is going to define a particular equipment is going to working in a particular satellite. So that is a continuous satellite is going to point in towards the specific accuracy and efficiency. Next, minimum performance variations caused by local wind and the weather. If there is a wind and there is a problem in the weather conditions, it is going to hamper your performance of the signal. It is going to hamper in the performance of the signal. And minimum variation in the illumination of satellite by the station. Okay, whatever the weather condition is not good, so it is going to hamper the particular signal. The variations should be minimum. And next, eye discrimination between orthogonally polarized signals. Most of the above design requirements are governed by the Earth station. that is G by T ratio. Almost all the stations are pointed towards the earth. It is going to decide a particular gain to transmission ratio. It is going to decide a particular gain to transmission ratio. So next, earth station major systems. Which are the major systems present in the earth station? One is antenna. Almost all. The most important thing, the parameter present in this earth station is your antenna. Transmit system, you require a transmit the signal from a station to a particular satellite. And receive system is required. You have to receive this particular signal at the station, that is the receive system. And power is very important for the receiving, transmit and the receiving signal. And the monitoring is also important at present at the earth station. What is the actual function of antenna system? The function is to transmit and receive the signal. Whatever the antenna present particular satellite, so the function of this antenna is to transmit the signal and to receive the signal. That is only the function of antenna. Transmit baseband signal. There is no modulation is present in this baseband signal, and uplink frequency is high. Always you have seen that is whenever the baseband signal is there, the uplink frequency is always high. The frequency bands we have seen, that is one is C band, one is Ku band, one is Ka band. The frequency band for C band is 6 by 4. Why it is 6? Always the uplink frequency is very high. Why? Because there is no modulation in the particular signal. So transmit system, there is uplink frequency is there, it is always high. And the receive system, there is a modulated. Already there is a changes in the frequency, there is a changes in the signal, there is a removal of the signal. So receiver system is a modulated signal, the downlink frequency is low. Power system you have seen in unit numbers 2, a battery and solar panels. Monitoring system and tracking system. These are the two main important systems which are present in the particular earth stations. And which are the design objectives present in that particular earth stations are, there are 4 principles. One is reliability and availability. What is reliability? I have explained you what is reliable. Whatever the equipments you are going to install in a particular satellite, is it working properly or not at the time of installation? Everything will be available and reliable. And link budget consideration, and budget is also very important. That is the 2 links we are using, one is uplink and one is downlink. That is link budget consideration. And next, customer driven objectives. Whatever the customers are required, a particular about the signals, they are going to consider those objectives, and based on that objective they are going to improve the particular antenna and particular satellite. Next, the special consideration applying to the teleports. Okay, these are the 4 design consideration we are saying, that is for earth station design consideration. And this is the revision for this parameter, that is what earth station parameters. All these parameters you already studied. All these parameters you already studied. That is, but we'll see one more time, that is transmitter power, the choice of frequency, which frequency you have to consider for a particular satellite. The satellites are based on your low Earth orbit, medium Earth orbit and high Earth orbit. Based on that, they are going to choose a particular frequency band for low Earth orbit, medium Earth orbit and high Earth orbit. And the gain of antenna, how much is the antenna is going to provide a particular gain. If this antenna, horn antenna, helical antenna, these are the different types of antennas present in a particular satellite. Based on that antenna, how much is the gain providing the particular satellite or the antenna, they are going to provide a particular antenna to the particular satellite depending on the gain. And the antenna is also depends on your efficiency also. How much is the efficiency? Is it a more than 95%? Is it near to the 100%? And based on that, they are going to consider a particular antenna. and the antenna pointing accuracy. These 3 points are very important for considering the antenna. For when they are going to consider a particular antenna, they are going to test accuracy of that antenna, efficiency of that antenna, and the gain of that antenna. These are the only 3 parameters they are going to see while testing a particular antenna. Next, noise temperature is also important. We have seen the noise temperature, that is total noise temperature, that is T is equals to T1 plus T2 plus T3, so on to T raised to n, that is n number. And the parameters is going to consider local conditions such as wind and weather. That is also very important. If the wind and weather is going to support a particular satellite, you will get a better signal. And the polarization of particular antenna, if it is linear or in circular, and propagation losses. The losses are important. If there is a gain, there is a sum of the losses present in a particular satellite. These are the main important parameters are going to useful for Earth station. Transmitter power is important. Choice of frequency is also important. Next, antenna, gain of antenna, antenna efficiency and accuracy, noise temperature, local conditions of wind and weather, polarization, linear and circular, propagation losses. Previously, we have seen the G/T ratio also. We have seen some of the a small derivation we have seen, that is gain to transmission ratio. In that gain to transmission ratio, you have to consider only the gain with respect to the noise temperature. What is the actual function it is going to do? The G/T is antenna gain, that is to be measured in decibel, minus there is a division is there, so minus of system noise temperature you have to calculate. So signal of the receiving antenna is increased by the antenna gain. Whatever the signal you are getting, if the signal is better, antenna gain will be increases, efficiency also increases, and accuracy is also increases. If the signal, there is a loss in the signal, if there is an undesired signal, unwanted signal, there is a noise, more noise is present in a particular signal, so the performance will be less. So that is subtract out of the system noise temperature. Whatever the signal we are getting at the Earth station, if the noise is present, okay, we have to subtract that particular noise, and we have to calculate a particular accuracy, efficiency, and gain of that particular signal. And this is you have seen in the noise, you have studied in analog communication also. Noise, different types of noise, internal noise and external noise. Okay, the internal and external, there are two sources of noise. The noise arising in the satellite and Earth station equipment, okay, always 100% we accept that is noise is present in the signal, while 0.1% is also present in a particular signal. Noise collected by satellite and Earth station antennas, whatever the noise is collected, that is to be present in a particular satellite and Earth station antennas. And finally, you have to calculate noise power. That is noise power, that is Pn or N is equals to KTB. And you have seen this KTB is what? Boltzmann constant and temperature and the bandwidth of this antenna. And next is radiated power. The radiated power is nothing but what? The transmitter antenna power and the receiver antenna power. That is PR, PT and PR. GT and GR, that is same. Based on this, you are going to calculate a particular effective isotropic radiated power. Effective isotropic radiated power you are going to calculate. Okay, that is transmitter output power plus antenna gain. And what EIRP includes? It includes an antenna gain, the gain of particular antenna. This you have studied these parameters, that is efficiency required, transmitter output power is required, and you have to use, there is a gain, there is a losses. So coupling and wave losses is also required for radiating power. Next point, what he has written, the once the ERP is known, no additional information about the transmitter is required. Once we calculated the effective isotropic radiated power, effective isotropic radiated power is nothing but it is a combination of PT and GT, that is transmitted power and the transmitted gain. Once we know this, so no need of any information. That is over. The ERP reforms assumes the transmitter is pointed directly to at the receiver. So ERP is nothing but what? Whatever the signal you are transmitting from the transmitter end, once it is reached to the receiver, that is going to calculate the how much is the transmitter signal, how much is the received power. That is directly calculated to the receiver. And this is your third parameter. And the fourth parameter is your path loss. What is path? A distance. Path is nothing but a distance. How much is the distance you are required? If there is a less distance, the losses will be less. If the distance is more, the losses are more. So that is what? A path loss. A signal radiates out from a point source. If the distance is high, the signal will be, it may divert from one point to the other point. Based on this, you are going to calculate a flux density, that is PD. You have calculated PT, GT, GR in lambda square divided by 2 pi d square into lambda square, I think, R square. That is a flux density equation. Is the less at receiving antenna as the distance increases. Okay, distance, how the distance goes on increases, the flux density will be decreases, not that much decreases, increases. The path loss is actually a dispersion of transmitted signal. Whatever the transmitted signal is there, that is going to calculate the path loss. The last parameter is the propagation effects of Earth. Which are the propagation effects of Earth? Propagation of signal, the radiation of signal. Propagating and radiating, both are same. The first effect is operating frequency. Based on the selection of the operating frequency, they are going to affect a radiated signal. Antenna elevation angle. Elevation is nothing but what? If there is in a 0 degree Celsius, if there is in a 30 degree Celsius, 60 degree Celsius. Okay, that is based on the elevation angle. Polarization. The antenna should be in a linear or in circular. Okay, that is a polarization. Next is the height of satellite from the Earth station. That is Earth station altitude. Earth station altitude. Altitude is nothing but what? The height of particular satellite from the Earth station. That is also one of the effect is going to affect the particular signal. And Earth station noise temperature. How much is the temperature is present in a particular signal? That is going to affect a propagation or the radiated signal. And local meteorology. Meteorology is nothing but your wind and weather conditions. That is meteorology. And last is your climate. This is what Earth station parameters. The parameters we are going to see, so that is G/T ratio, noise, radiated power, path loss, and propagation effects of Earth. Okay. And the next point is Earth station testing. Earth station testing is similar to that of your second unit. You have seen in that second unit one point, that is equipment reliability and space qualification. Equipment reliability and space qualification. You have to write same explanation of equipment reliability and space qualification. What is equipment reliability? Reliable is the particular equipment is reliable or not. Is it qualified or not? Everything will be calculated, everything will be tested at the Earth station itself. That is what Earth station testing. Earth station testing is not testing the ground or the Earth. They are going to test a particular equipment at the Earth station. That is what the meaning of Earth station testing. Which are the mandatory tests they are going to do at the Earth station? That is very important. The mandatory test they are going to do as a transmit cross polarization isolation. Polarization of particular antenna is very important. That is a test. If we have to maintain a particular antenna in a polarized, that is in linear or in a circular, if you have mounted a particular antenna in a linear, the signal will be effect or not. If you mounted in a circular, how much is the signal is going to effect? How much you are going to get a gain? How much you are going to get efficiency? How much you are going to get the accuracy? That is only the point where we are going to use this transmit cross polarization. The figure of merit, that is very important. Receiver, FOM. Next, always you have to calculate the EIRP, effective isotropic radiated power, and the spectral shape of a particular antenna, shape of particular antenna, horn antenna, helical antenna. These are some different types of spectral shape. And you have seen this structure in a station architecture also. One is source, information signal, high power amplifier that is connected to your antenna. That antenna gives a particular signal to the satellite. Okay, that satellite is going to modify the signal and changes the frequency. That changes frequency will be given to the at the receiver antenna. Receiver antenna is going to have a low noise amplifier. This low noise amplifier is going to provide a particular regenerated signal, that is the original signal, with a removal of the noise, with a decrease in the frequency, and there is a subsystem is present at the receiver. The receiver subsystem is going to do this all these functions. That is a receiver figure of merit, that is EIRP, effective isotropic radiated power, and your spectral shape. Finally, all these functions will be controlled and the monitoring equipment will be done by based on the earth station. And this is for a receiver side, and this one is for transmitter side. The transmitter side is different and receiver side is different. That is a reverse. Transmitter subsystem, high power amplifier at the control and monitoring equipment, low noise amplifier, receiver, and spectrum analyzer. The receiver figure of merit, this is the transmitter figure of merit. The last point of this unit is radio frequency equipment for earth station. How much is the RF frequencies required? RF equipment. Okay, this diagram is similar to that of your earth station architecture. Okay, one is up converter, one is down converter. At the receiver end, we require a down converter. At the transmitter end, we require a up converter. Okay, in between this, we require intermediate frequency. Intermediate frequency is to do the subtraction of the signal. The subtraction of the particular signal is to do the removal of the particular noise. Okay, both the transmitter end you are present a high power amplifier, and the receiver end we require a low noise amplifier. Okay, for the removal of the noise, that is a low noise amplifier is required to take the signal from the up converter from the transmitter from the earth station to the particular satellite of the antenna. We require high power amplifier. So these two are very important as a equipment, as a part of this the system. So high power amplifier at the transmitter end and the low noise amplifier at the receiver end. The main function will be done by these two blocks. So one is high power amplifier, one is low noise amplifier. So up converter is to increase the signal. That is a baseband signal can be reached to the particular high power amplifier. The function of amplifier is to amplify the signal, against to increase the signal, that baseband signal. Through this waveguide that reaches to the particular antenna. That antenna reaches to the particular satellite. The satellite is having a particular antenna. The function of that particular antenna is to change the frequency and particular modulated signal that is to be converted from modulation to modulated signal and given to the particular receiver and the low noise amplifier to remove the noise, everything, and that has to be down converter is to receive the particular receiver signal at the original signal at the receiver end. This is a explanation of the RF equipment for earth station. This is similar and radio frequency equipment for earth station. Same diagram he has given. What is written? RF equipment comprises up converter, high power amplifier, and the transmit antenna in the transmit channels, and the receive antenna, low noise amplifiers, and down converters in the receive channel. Okay, these are all the blocks present in a particular RF equipment of earth station. These are all the blocks, very important blocks present in this word. The high power amplifier, one is high power amplifier and one is low noise amplifier. The second point is, while the output of high power amplifiers feeds the transmit antenna, the receiver antenna is connected to the input of the low noise amplifier. So whatever the signal we are transmitting from a converter, that is a baseband signal, that baseband signal is again require energy. That energy is given by the high power amplifier, and that is to be reached to the particular antenna. So that is required a high power amplifier, a block. Next, the transmit and receive antenna functions are almost invariably performed by the same antenna. So what is the transmit and receive antenna is doing? It is invariably performed by the same antenna. Whatever the antenna, it is using only one antenna for the transmit and receive of the signal. From the viewpoint of EIRP, that is effective isotropic radiated power, and also our station, G by T, it is always desirable to have a minimal losses in the waveguide. If the G by T ratio is good, that is gain to transmission ratio is good, so we have to calculate the good EIRP of the signal, that is effective isotropic radiated power of the. So we required the two links, one is uplink and downlink for a selection of equipment. What are the different types of equipments we are using in this? We are using equipment as a main equipment as high power amplifier and the secondary equipment as low noise amplifier. These are the two main equipments we are going to consider. And how they are going to do a particular maintenance of that particular equipment. Two tests that they are going to do. One is testing the requirements and equipment requirements. In this testing requirements, one is antenna. There is a losses, alignment is required, and correct alignment is required, polarization of particular antenna, and side lobe levels. Then the transmission lines, where it is going to take a particular cables and the waveguide losses, and the fault is located at a particular transmission line. You are going to test while we are going to install a particular cable lines. And the transmitter side, we require a high power amplifier performance. We require converter, that is up converter we required. How much is the bandwidth we required, the occupied bandwidth, and the power is required, channel power, and frequency stability. Is the frequency stable or not? That is also one of the main important thing in this. That is for the transmitter end. And the receiver side, we have seen that is low noise amplifier is required, the performance of that low noise amplifier. Again, the converter and the interference of the two signals, and the GPS mobile application, global positioning system. Okay, that is also one of the important. The next point is system. The system, the main function of system is to do the EIRP, that is effective isotropic radiated power, G by T, and carrier to noise ratio. And the B side, we are using equipment requirement, which are the main equipment we are required in this. One is power meter, how much is the power required for particular equipment. Second is spectral analyzer. You have to analyze the particular frequency of the signal, how much is the frequency. And RF source, radio frequency source is required, and the DC source, that is direct current. And this is what a full unit of this Earth station. In the Earth station, we have seen, just I will be wise for 5 minutes. In the Earth station, the main important thing you have to concentrate is of parameters which are going to calculate at the station. One is your EIRP, one is your GYT ratio, and which are the techniques we are using in this. That is also very important. So we are using the different types of Earth station. Stations are going to provide a particular services, that is fixed satellite service, broadcast satellite service, mobile satellite service. This is second point. And third point is single function station. Your the cable, TV cable, which is mounted at the top of your house, that is your single function gateway station. And station architecture. This is very important for this unit. That is, you have to explain. For offline, if it is there, they will ask for 6 months. You have to explain the architecture of Earth station. This is baseband signal section, RF section, and support facilities. These are the different blocks we are going to use. After that, you have seen the design considerations. By designing the Earth station, which are the parameters we require, and we have to see the different parameters of Earth stations. And the lastly, we have seen the RF equipment for Earth station. So this is what the unit number 4. So tomorrow we'll start the unit number 5. The unit number 5 is too small. It is of only 4 points are there. So it takes only 2 lectures to complete the 5th unit. Only 2 lectures it is required, that is of propagation effects. I think you have studied the ionosphere, troposphere. That is related to your weather conditions. Tomorrow and Saturday, it requires only 2 lectures to complete the 5th unit. And after that, on Monday, I will take the unit test 4. Monday, I will take unit test 4, so be ready for the test. Okay. So be serious about your attendance and give concentration on the lectures. The exam may take online or offline based on the decision of the university. If you come in defaulter, so you will be responsible for that. Still, the strength is too less. I don't know what the problem of remaining students. At the starting itself, they are started giving the attendance. No, means they are not interested.